So here's the demonstration of how to make a scatter plot using Microsoft Excel and how to project a best fit line or a trend line through it. And this is going to be using the data that you find in Table 1 of the lab packet. So I've opened up an Excel workbook and a worksheet, I'm sorry, and it looks like this. It's my blank worksheet. So I want to start by typing my data in. So I'm just going to go to Table 1 in the packet and copy that. In one column we have concentration. I'm going to type concentration. I'm putting percent there in the heading, not after every number. I'll tell you about that in a second. I'm going to go to each cell and type in the numbers. I got 12%, 21%, 28%, 36%. Now, first thing I notice is, hey, the word concentration doesn't fit in the width of the column. I can easily fix that. If I put my cursor between A and B, I get that little double arrow thing, and I can click and drag the width of the column, or I can just hold it there and double click, and it will automatically resize that column to the proper width. In the other column, I'm going to have optical density, or OD. Remember that optical density values don't have a unit. They're one of the few times in science that we see a unitless value, so they're just numbers. So I'll type the numbers in from Table 1. I get 0.14, 0.25, 0.37, 0.42. Again, you can make that as wide as it needs to be. Now, before we make the graph of this, let's just do a few visual kind of cosmetic things to it if you want. What I'm about to do is just purely your preference. It just makes it look nicer and easier to read. For example, let's say I want these values to be centered in the cells. I can circle that, and I can go up to my centering tool up here and click center. Maybe I want the fonts to be bigger. Maybe that's too hard to read, so I go circle those and I add a little bit of size to those fonts. Again, if the term in the cell is too big to fit, just double click and it will fit. Maybe I want the headings to be bold. I can circle them and hit bold. In other words, any of the tools that you have to edit things in a word processor, you've got them here in Excel. One last thing I'm going to do here, I like to have grid lines on my spreadsheets. So I'm going to circle here, I'm going to go up to the grid line tool, and I'm going to pull that down and go to all. And now I've got grid lines around there. It makes it easier to read. Anyway, that's my data set. We want to make a graph. In this case, the graph is supposed to be of 4 points. This is an x value, that's a corresponding y. X, y, x, y, x, y. Remember how to plot graphs on a plane. You've got an x value, comma, y, x, comma, y, x, comma, y, x, comma, y. So we should have 4 points when all is said and done. The x values are these, the y values are these. In other words, these need to go on the x-axis, that's the horizontal axis. These need to go on the y-axis, that's the vertical axis. So we want a graph to appear here. Let's go ahead and do that. Here's what I believe is the best way to do this. If you have done these before and you circle this and you just say, give me a graph, sure, you'll get a graph, but in this case, you're going to have the wrong things on the wrong axes. And honestly, in science labs, you typically don't have just 2 columns of data. You have many columns of data. So that method almost never works in real life. I'm going to show you the maybe more clicking, but better way to make a graph in Excel. I'm going to have my data ready. I'm going to click on a cell that is not occupied. In other words, not one that's got something written in it, and not even one that's adjacent to one that's occupied. I'm going to click on a blank cell somewhere out here. I go to the Insert menu, and I find Charts. And you got all these different kinds of charts. By the way, Excel calls graphs charts for whatever reason. You got bars and lines and pies and points and everything else. We just want a plain old simple scatter graph. Just 4 points on a graph, no connect the dots, nothing like that. So I click my little drop down menu and I select this option. I don't want this, I don't want this, I just want points on a graph. So click. And I get a blank canvas here because I haven't told it what I want it to graph yet. Notice that when I click on that canvas, I get a new toolbar up here. that toolbar includes select data. Now I can pick what data I want it to graph. So I click select data and I get a pop-up window. And the button right here is going to let me add a set of data. It's called add. Okay, so click there and I get 3 ribbons here. Series name, that's just going to be the title that appears on the graph. X values, Y values. Well, that's exactly what I wanted. I wanted to tell the graph, tell the software what should be X's and what should be Y's. So this is perfect. Give this a name first before you go any further. I click there and whatever I type here is going to be the title of the graph. Let's call it practice graph. Now, of course, when you're doing a real set of data for a lab report or a lab exercise or whatever you're doing, you would type a real title in there that's meaningful. But for this example, let's just call it practice graph. X values. I know I want the optical densities to be on the x-axis. So these should be X values. How do I tell the machine to do that? Well, here's how. Don't click or type anything in this ribbon. Instead, click the little button next to the ribbon. And when I do, this collapses, and I go over here to my spreadsheet and I say, I'm going to click, hold, and drag, which allows me to have circled those 4 values that I want to be on the x-axis. Go back over here, click that button again. For Y values, do the same. Don't click here, don't type here, don't do anything. If you do, Excel will get confused and it won't work. Instead, go over to this button, click, circle these, and click again. And then I say OK. And unless I want to add another set of data, which in this case I don't, I say OK again. And look at that, I got a graph with 4 points on it just like I wanted. It even looks like they're kind of in a straight line, and if you read the packet that goes with this video, that's probably not surprising. So far so good. I've got a title up here, I've got numbers that correspond to these numbers on the axes, and I've got my 4 points up there. Well, this graph wouldn't mean anything to anybody if you handed it to them unless you had labels on the axes, because they're going to look at these numbers and say, well, 0.15 what? 20 what? There's no units of measure here. So I've got to add labels. That's easy to do. I go to the plus sign here, click, and I check the box that says axis titles. And when I do, the words axis title appear where I should have labels. This allows me to click, overstrike, and type what I really want there. In this case, on the x-axis, that's optical density. Over here, on the y-axis, I do the same thing. I click, I overstrike, and I want that to say concentration with parentheses %, my unit of measure. Okay. Notice, by the way, that I never typed a % sign here or here or here or here. That was intentional. If I type a % sign after a number in a cell in Excel, the software is going to think that it should divide by 100, because the % sign to Excel means divide by 100, and my graph is not going to be correct if I do that. So I tell you the unit of measure in parentheses up at the heading, and on the axis title, of course, and then I just type raw numbers in here. Okay, so before we go any further, again, just some cosmetic things. If, let's say I want that title to be a little more prominent, I can click there and highlight that, and I can make it larger. I can make it bold. I can make it red. I can do, whatever you think is a good idea. Maybe I want these axis titles to be bold, so I can do that, and maybe that one should be bold too, so I can do that. So again, if you have tools up here, you can use them. It doesn't always mean you should. You don't want this to be 15 different colors. It'll look confusing, but do what you think you need to do to make that graph easy to read for your reader. Okay, the next step for this particular graph is I want a trend line. Again, please read the packet on this, but let me briefly explain what I'm talking about when I say trend line. Some people call a trend line a best fit line, a calibration line. If you've taken a statistics class, you may have called it a regression line. It's all the same thing. Here's what it is. I've got 4 little stories about data here, stories about how optical densities relate to concentrations of solutions. Got this and this and this and this. I want to take those little local stories and weave them together in such a way that I have a line that runs through or close to those points, and that line will be sort of my universal definition of what these little local stories are trying to tell me. That's what that trend line is. That's what that best fit line is. So that line may not actually hit any of these points, or it may hit some and not others, but it's going to be at least very close to each of them. Now, if I can't just take a ruler and hold it up there and draw a line, that's completely arbitrary, and that means absolutely nothing. And if anyone's ever told you to do that in the past when you made graphs on paper, they did you a disservice, because that was a meaningless exercise. There's a mathematical way to take the data that each of these points are telling you about and project a line, extrapolate a line from it. Fortunately, we're working on a piece of software that knows how to do that math, and we don't have to do it ourselves by hand. Here's how to get that best fit line. I'm going to pick any of those 4 points that I want. It doesn't matter which one, just choose one. I'm going to put the cursor on it with a little arrow there. I'm going to right click. I hit the right mouse button, and one of the options I get is Add Trend Line. So I click it. And when I click Add Trend Line, first of all, notice that a line segment appears, and that's good because I expected that to happen. Notice that the points are, some of them are on it, some of them are close to that line, but that looks like that line is telling me a pretty good story based on what those points are showing me. But more to the point right now, this other window on your right-hand side of your screen popped up. So what it's telling you over here is, yes, I put a straight line in there. That's why linear is pre-checked. But what you want to do is check the box that says display equation and check the box that says display R squared. Again, if you've read the packet already, you know why we're doing that. I'll explain it again in a second, but I have to check those. Otherwise, this whole exercise is pointless. I close that box and I go over here and I say, oh, look at that. I've got an equation, and I've got this thing that says R squares equals blah, blah, blah. So I'm going to make that a little bigger. It's easier to read. Maybe make it bold if you want to. Do whatever you want to make that easier to see. In fact, watch this. I can go to that area. Let's click over here. I can go there, right-click that, and I can add some fill. I could maybe put some highlighter behind it like that, make it easier to read. Again, whatever you think makes this prominent. So what do I now have? First of all, I have an equation. Y equals mx plus b. That's the format for an equation for a straight line. This is the equation that defines this line, and this line is telling me the global story that these little local points are suggesting. This line defines the relationship between the optical density of the solutions used in this experiment and the concentrations of the solutions used in this experiment. And that's exactly what I need. I need a mathematical definition of the relationship between this and this for each of the 4 solutions that I used. In other words, everything you've done up until this point was just to get that equation. That's all that matters. The R squared is there just to verify that this is trustworthy. Now, if you take a statistics class, they'll give you the formal definition of what this means. This is a square of what's called a correlation coefficient. And without getting into the details of that and what all that means, let me just say something that's not literally true in a statistics class, but it'll give you a feel for what that value is telling you. If I were to use this equation to draw a conclusion, I'd be 97.36% confident that that conclusion is real and not just random chance, that it's really based on the data. In other words, the closer this number is to 1, the more confident I am in using the equation that goes with it. In this particular type of graph, I'd be pretty happy if it were 0.9 or above. Well, I got a 0.9736. That's really good. I'm going to trust this. Really, it's there so that if anybody looks at your graph, they're going to look for your R squared and say, should we be believing this or not? And with that number on this type of graph, they'll believe it. Okay, this is trustworthy. I'm going to make that a little smaller now. We'll never use that number in a calculation, we're going to use this in our calculation. Again, see the packet. You already know that this equation is going to be used. So in any case, there's your graph. That's how to do this. Please, please, please be fluent and confident in making a scatter graph, projecting a best fit line through it, and getting an equation and an R-squared that goes with it. In future weeks, we're going to use this type of graphing, but we're going to throw a twist in each time. Sometimes it's not going to be a straight line. You're going to have to change that up a little bit. Other times we're going to put more than one line on a graph. So each week when we graph, we're not going to graph every single week, but each time we make a graph, we're going to add a new feature. So it's essential that you're comfortable with the basic graph like this. So practice this. Most importantly, take the data that we generated in the previous video where I did the optical densities of the solutions. You've recorded those in the table in the packet. Take that set of data and make the graph that goes with it and answer the question at the end of the lab exercise. Use the graph, use the equation to determine the concentration of the unknown solution. Again, that's based on that video that is also part of this lab exercise.